Hi, today we are going to see this question from a Riemann integral. So if f is defined on in closed 0, comma 1 by fx is equal to x for all x belongs to closed 0, 1, then we need to find UPF, then LPF, then integral 0 to 1, that is upper sum 1 fx dx, then integral lower sum 0 to 1 fx dx, that we have to find it. Okay, so for that first we need to find UPF. So before finding these values, first of all we have to divide the partition, right? So here we have 0 to 1. So you can write partition P is equal to 0, okay, 0 to 1. We need 0 to 1. So that I am going to take this is 0 divided by n, then 1 divided by n, 2 divided by n, etc., etc. The last one n divided by n, that is equal to 1. Be the partition of 0, 1. Okay. Now I have to, so this is the first one we have to do the partition. And the second case, this is the first one, and the second case you have to write the subinterval that I am taking as IR. So IR is equal to, we need to write the subinterval. Here you can see 0 by n, 1 by n. Right? If I am take r by n here, so if I am take r is equal to 1, so it is 1 by n. So here it is r minus 1 by n. So that only I am getting here 0 by n, right? So if I am take r equal to 1, what I am getting 1 by n, r minus 1 means 0 by n. If I am taking r equal to 2, what I am getting, that is equal to 2 by n, here it is 1 by n. So it's satisfied. So r carries the values 1, 2, 3, etc. Okay, 1, 2, 3, etc. up to n. Now, the third one we have to find delta. So, delta r, that is equal to what means Ri minus 1. Okay. So, here you can see that this value I am taking, that is equal to r by n minus r minus 1 divided by n. That you can take. R minus 1 divided by n, that is delta r. So these are the three and one more we have to find MR or MI, that is equal to the highest of this this value, that is equal to r by n, and the small mr is equal to the lower, that is L r minus 1 divided by n. So these are the four we need to have before finding these values. Okay, the first one, the partition, we have to subdivide it interval, then we have to choose the subinterval, and from this we have to find delta r, that is upper minus lower limit, and mr is the higher value and small mr is equal to this value. Let's find out UPF. So let's see how to find UPF. The formula here is UPF, which is equal to summation r is equal to 1 to n mr into delta r. Okay, so that is equal to summation r equal to 1 to n mr we found out as r by n, and delta r is equal to r by n minus r minus 1 divided by n. If you substitute the value, summation r is equal to 1 to n into r by n. From this you can write that r minus 1 by n, right? So that we will get, which is equal to summation r equal to 1 to n r divided by n square, and I took 1 by n square outside and substituting r equal to 1, 2, 3, etc. to n, that is 1 plus 2 plus etc. plus n, and which gives 1 by 2 into natural number, first natural number whose sum is n plus n into n plus 1 divided by 2. So that I am getting n plus 1 divided by 2n, and while separating 1 by 2, so that 1 plus 1 by n. This is the value of UPF. And then we can find the LPF. So LPF, the formula is summation r is equal to 1 to n small mr into delta r. So it is equal to summation r equal to 1 to n mr value is r minus 1 divided by n, and delta r value is this one. So that we can find here itself, that is 1 divided by n, right? So r minus 1 divided by n and 1 divided by n. So r minus 1 divided by n into 1 divided by n. So I am taking 1 by n square outside. So r equal to 1 to n into r minus 1. Substitute the values so that I am getting 1 minus 1, which is 0, 2 minus 1, 1 plus 2, etc. Then r equal to n minus 1, right? So which is equal to 1 by n square. Then here we have the same formula. First in natural numbers. Such a way you can take. So that usually here 1 plus 2 etc. up to n means we write that as n into n plus 1 divided by 2. If it is 0 plus 1 plus etc. up to n minus 1 means that it will be changed as n minus 1 into n minus 1 plus 1 divided by 2. Okay. Using this we can write it. Okay. So here it is n minus 1 into n minus 1 plus 1, that is n divided by 2. So we can cancel this, which is equal to n minus 1 divided by 2n. I am taking 1 by 2 outside, so 1 minus 1 by n. That is the value of LPF. Now the question asked two more, that is integral, that is upper integral fx dx. So here already we found out this value, that is UPF is equal to, right? So the question here, upper integral 0 to 1 fx dx, that is nothing but which is equal to GLB of UPF. Okay, GLB of UPF. So GLB of UPF is equal to what? The value here, you can substitute the values n equal to 0, 1, 2, 3, etc. So just I am writing limit n tends to infinity of these value, okay, of this value. So 1 by 2 into 1 plus 1 by n. As n tends to infinity, 1 by n tends to 0. So I am getting the answer is 1 by 2. The same I need to find for this one. That is, I need to find for this one. That is integral lower sum 0 to 1 fx dx. Lower integral, which is equal to what? UB of LPF. Okay. So which is equal to, I am taking limit n tends to infinity of this value. LPF, that is 1 by 2 into 1 minus 1 by n. Apply the value, you will get that is equal to 1 by 2. So this is the how we are going to, we need to do upper Riemann integral and the lower Riemann integral. Similarly, we can find another one question. So here is the question, let B is equal to partition 0, 1, 2, 3, etc. 0, 1, 2, 3 with a partition of close to 0, 3, and if the function is given fx is equal to x for x belongs to 0, 3. Okay, here is the function is given. So let's see how to find this one. So for that, so first of all, we have UPF, that the formula is summation R is equal to 1 to 3, right? Because in the question itself, it is given 3 partition, right? So then MR into delta R, or you can write this delta R. So which is equal to, you can write M1 delta 1 plus M2 delta 2 plus M3 delta 3. So the partition P is equal to, 0, which is equal to, you can take 0 by 3, then 1 by 3, then 2 by 3, then 3 by 3, which is equal to 1, right? Then you can write delta R. Delta R is equal to R minus 1, right? R by 3 minus R minus 1 by 3, right? So that what we are getting the difference, which is equal to 1 by 3. Then we can find MR. So the subinterval itself 1 by 3 minus 0, or 2 by 3 minus 1 by 3, or 3 by 3 minus 2 by 3. So here we need to find like this. M1 is equal to 1 by 3 minus 0 by 3 into delta 1. Okay. delta 1 each time we have to do this one. That is equal to what? 1. So before doing this, let's have the 3 conditions here. So it will be easy. So first one, we have to do the partition, and the second one, we need to do the intervals, right? So first interval I am taking as, here it is 0 by 3, that is 0, 1 by 3, okay? And the second interval I am taking as I2 is equal to 1 by 3 and 2 by 3. And the third one I am taking as I3 is equal to 2 by 3 and 1. Okay. So here you can find delta R. That is equal to the difference between these two. 1 by 3 minus 0. That is 1 by 3. And here capital M1. That is equal to the upper value here. That is 1 by 3. And small m1 is equal to the lower one, 0. Similarly here delta, this is delta 1, okay, and delta 2 is equal to the difference between these two, that is equal to 1 by 3, and capital M2 is equal to 2 by 3, the highest value, M2 equal to the lower value 1 by 3. Again you can see here I3 also delta 3 is equal to 1 minus 2 by 3, which is 1 by 3, 3 minus 2, yes. And here capital M3 is equal to 1 and small m3 which is equal to 2 by 3. Okay, so you have to see whether the function is given here. But for the last problem, the function is not given, so we can write easily. But here f of x is equal to x is given. So here the little difference will be happen. So what you have to do is just check this one. M1 that is equal to M1 that is equal to f of, right? F of x is equal to, here it is M1 is what? 1 by 3, right? So f of x is equal to x. Then here M2 which is M1, small m1 which is equal to f of 0 that is equal to 0. Actually this is correct. The function is given. So according to the function only you have to write. If the function is not given directly you can write this. This is the higher value and this is the lower value. The function is given, so must you have to note this one here. F of x is equal to x value. Similarly, this also will be right, because f of x, that is f of 2 by 3 is equal to 2 by 3 and f of 1 by 3 is equal to 1 by 3 and so far. Right? So now we can substitute all the value. Capital M1 that is equal to what? 1 by 3. Delta 1 is 1 by 3 and M2 is 2 by 3 and delta 2 is 1 by 3 plus M3. Capital M3 is 1 and delta 3 is 1 by 3. 1 into 1 by 3. So that we are getting 1 by 9 plus 2 by 9 plus 1 by 3. So which is equal to 3 by 9 plus 1 by 3, which is equal to 2 divided by 3. Right? So this is 2 divided by 3. The same you have to do for LPF. So the values, everything will be there. Instead of capital MR, you have to use the small value so that you will get the exact answer. So this is how we have to find for the partition if the function is given. Okay. So for the last problem, the function is not given, so it be done very easily. But here the function is given. So instead of M1, that value, you have to put this values. Okay. So this about the upper Riemann sum and the lower Riemann sum. Let's see the next question. Okay, we are going to do this one. So the function is given as 2x minus 1 on closed 0, 1 and the partition is given as 0, 1 by 3, 2 by 3 and 1. So this is the first one. So first you have to write the subintervals, right? I1 is equal to, I am taking 0, 1 by 3. So that delta 1 is equal to what? 1 by 3 minus 0 is 1 by 3. And second one M1 which is equal to here f of 1 by 3. Okay. So function is given now which is 2x minus 1. So that is 2 into 1 by 3 minus 1 which is 2 by 3 minus 1 which is equal to 2 minus 3 divided by 3, that is minus 1 by 3. And small m is equal to f of 0. Right. This is M1. This is capital M1. So here the function is given. So f of 0 is equal to 2, 0 minus 1 which is minus 1. In the same way you have to do I2. I2 is equal to 1 by 3, 2 by 3. So that delta 2 is equal to 2 by 3 minus 1 by 3 which is equal to 1 by 3. and m2 is equal to f of the upper value here is 2 by 3, and apply the value 2 into 2 by 3 minus 1, which is equal to 4 by 3 minus 1, which is equal to 1 by 3, and the small m2, which is equal to f of 1 by 3, that is equal to 2 into 1 by 3 minus 1, which is equal to minus 1 by 3, right? And similarly, we have to find for I3. So I3, the interval is 1, comma 2 by 3, the interval here, right? So that delta 3, that is equal to 2 by 3 minus 1, which is minus 1 by 3, and m3, which is equal to f of 2 by 3. F of 2 by 3 we found out here, which is equal to 1 by 3, and small m3 is equal to f of 1, that is equal to 2 into 1 minus 1, which is equal to 1. So all we find out. So just substitute this in UPF and LPF. So UPF, yes. So UPF, the formula is equal to summation R is equal to 1 to 3, because 3 we need have, that is partition. Then m r into delta r, so that m1 delta 1 means the value is here m1 and delta 1, so minus 1 by 3 into 1 by 3 plus m2 delta 2, m2 delta 2, so plus 1 by 3 into 1 by 3, then plus m3 delta 3, m3 is 1 by 3 and delta 3 is minus 1 by 3, 1 by 3 into minus 1 by 3. So substituting these two get cancelled, which is minus 1 divided by 9. In such a way we have to find for LPF. So LPF. So this is the way of doing Riemann integral. Hope it helps you. Thank you.